before the cube. Usually we put it on the top or just after the clear color. So if I want to move it somewhere else, I can take the shape, shake it, then it starts to disconnect, and then I can, connect it below. But I think it was a bit clearer with all the cables that we had, so that's why I put it here. So, and when you have this, I'm saving my patch again. What it happened now, what it allows you, so there's tons of options for sure, like allowing panning, zooming, and rotation. Now, if I go here in the scene, now check that I can move. You see, I'm pressing my left button, and I can really go around and move and see what is happening here. Does it make sense? You can even pan with the right click, and with the mouse wheel, you can zoom in and out.
No, it's not working on my side. I don't know for the others, but I have issues connecting the orbit controls on the main loop.
Same here. Oh, it just worked. I had to move it around a little bit.
Yeah, I mean, it needs to be right. We needs to be, you see, clip and connected, right? And then it's like this, right? Otherwise, it's just, maybe it's in between, but it's not actually connected to the cable. Once it's connected like this, does it work for you?
It's working now for me.
Yeah, okay, it's working now. You have to connect clear color before connecting to main loop.
What? No. The orbit controls, you can put this after. Huh? It doesn't change. It's irrelevant of the position. The orbit controls is about the camera. It can be put before or after the clear color.
Okay.
But it needs to be put before you draw the shape, because otherwise the camera is going to move, but the shape is already being drawn, so it's too late.
Sure.
Right. And so then you can allow or disable like rotation, panning, and zooming. If you are really lost, like if you are far away, you don't know where you are, you can go click here on the reset button. So it will recenter everything again. So it's quite handy also. So I'm going to remove this guy here, try to clean and control it. So now we have a way to rotate our camera and also move our cube and everything. So we start to have all the elements we need to do some interesting visuals. So one thing that we could do would be to draw several cubes instead of just one cube, right? Because if let's say that you want to recreate this animated bar chart, well, a bar chart is just a bunch of cubes, rectangles that we put next to each other, right? Does it make sense?
Yeah.
So the silly way of doing that would be to, okay, I need 4 cubes. So I'm going to copy and paste, Control-C, Control-V, and I'm going to connect stuff here. I don't know why.
That's a silly way.
It's silly, right? So I'm disconnecting everything. So just to, so that it's less straining on there. It's silly, right? I need 100 cubes. I'm not going to do this by hand. It's silly. Notice first that when I can actually connect several triggers, but I have no guarantee of which one is going to be executed first. So usually when you have a different cable that, the yellow cable that needs to be split or any other cable, you can use what we call a sequence up. This will make sure that first we do this, and so I can connect this, for instance, here. And this guy would say, first we do this operation, and then we're gonna do this one. And check this out. I'm gonna move the position of my cube here, and I'm gonna reset the camera because we're not really sure where we are. Now we see better. Notice what happens here. In this sequence here, I'm moving my cube on the left, -1 meter on the left, putting the material and drawing it. Here, I don't have any material, so I can say, hey, maybe I need to share the material, or maybe not. Maybe I want to put another material. So one other material would be a basic material, for instance. No shading, just a pure color. So I'm going to put this basic material and put this to blue. So this one is just is usually used to color particles, so you don't need the shadows, and it's less resource hungry on the CPU and GPU. So notice what happened. This cube here, I have no transform, so I cannot move it. It's at the center, but this guy here, I can move it around, right? I can do this. And notice what happens when they are both on top of each other. We have this kind of, we call the Z fighting, because they are exactly in the same plane. You have this kind of a weird aliasing and artifacts. So the way to do that is to just push one at a different Z value, and so that one is above the other and there's no colliding on the same plane, basically. Right? So I'm just moving my cube around. Does it make sense?
What are the color of the line for? The yellow, green, and
it tells you what type of input you pass along. The green is numbers or Boolean value. The yellow are triggers, so like calling the next block, function call, basically, if you have come from the programming background. This purple here is about an object, any type of JavaScript object. So it's basically the default stuff if you don't know where to do this. And then we have two other colors that we're going to see, the string and the array. So basically different data types that you pass along.
And you will use arrays right now.
Yes, we're going to use the arrays because we're not going to... But I just want to show you this. I think it's important to see this idea of the sequence here. This operation now does not share the same transform, whereas let's say that I would put this transform here. I'm shaking it and I put it before. Now both cubes are drawn on top of each other because we put our position at the same place, and even though we see we put two cubes, they are on top of each other, so they're completely hidden, right? Because they share the same transform. So if you want to put several geometry, they each need their own transform to work, right? So I'm going to shake this again and put it back to my first cube. Does it make sense?
Yes.
The yellow is the trigger, right? It's the function. It's what are you going to call? I'm triggering it really like, hey, now do this. And this main loop is saying that 60 times per second. Now, what comes next? Right? This guy, then this guy, then this one. And here I'm splitting. First, I'm doing this chain here, and then I'm going to do this other chain. So I have this sequence here that I can put as many outputs as I want. And the green objects are just numbers, the inputs that saying, oh, I'm going to do either a number or it's written here, right, in square brackets, number of Booleans. True, false value are numbers. Okay. So, okay, now we want to have 3 cubes. I'm not going to copy paste thing. It's silly. So I'm going to show you the simple way, inefficient way, and the correct way to do this. And it's important to get the underlying principle as well. So I'm going to remove this. I'm deleting this. I don't need that. And I'm going to use it's called repeat, which does exactly what you expect it to. So if you come from a programming background, this is a for loop, right? This is just a loop that says how many times you want the underlying operation to repeat. So I'm going to disconnect this guy here and say, okay, now I want to repeat. By default, it's 5 times, okay? So I'm going to repeat whatever comes below this trigger 5 times. Now I'm connect this to my transform, and then you will see only 1 cube. Can anyone tell me why?
They are all at the same position.
Yes, right. They are all. So we actually have 5 cubes, but they are all at the same position. So the other output so the repeat is this guy, and press the F key to have the flow mode, and notice that this is repeating, right? It's faster. The lines here, they are moving faster than this one to show you that this is being repeated. Now you use this index value here, and you can connect it to anything. So even though it's written 4, it's counting, right? So it's going, programming will start at 0. So 0, 1, 2, 3, 4. So how would you put the cube next to each other now that you know there are actually 5 cubes?
You link the index to the position, X position, for instance, in the transform, but you will have to multiply. Okay.
Is it clear for the rest? Is it because we are only a small bunch? How many? We have 3 people. So you guys have all programming backgrounds, more or less.
I'm 0, but I'm learning on the go.
Okay. It's fine.
Yeah, I have a programming background.
Okay. So really, if you want to see the implementation of the repeat, you can go here. Once again, it opens this editor, and you know that this is, you have two forward and backwards operation, but it's going to do a for loop, right? So it is just a for loop. And of course, we connect the index to this position. And as you said, we need to multiply, so that instead of going 1 meter by 1 meter, we say no, it's going to be 2 meters by 2 meters, or just 0.5 meters, right? And then we can move around, and then we can really, with this just small multiply, change the, and notice when it's too small, it looks like a cube. So if you put 0 and you link this to whatever, this divide that we had before, you can create some nice animation, some kind of bouncing stuff. But I think it's still very slow. So let's I don't know, put our timer, or you can put another timer if you want. Let's copy, pasting my timer here, put next to multiply, and putting our whatever, our absolute sign and absolute value, for instance. I'm copy pasting stuff around. And I'm not sure why I'm doing this. It's still going to be between 0 and 1. And if I play it, now you see that, right? And you can really see the effect of the bouncing that we had before, right? That when it goes back, it goes up very quickly. So we can create this kind of animation, and notice that everything is still connected. So I can do this, but I can still move my camera around, and it's completely unrelated, right? You can really move around. So it starts to be cool, right? You can create some shapes and still have everything connected. And notice how you can also experiment stuff. I don't need to disconnect it. If I don't like this anymore, I just disconnect it. But I didn't delete this code, right? It's not being, here in this case, it's being run with the timer. But I can leave dangling, leaves and branches, and connecting back when I want. When I'm sure I want to test this feature, right? So now we have our cubes, and as I mentioned, this is the dumb way of doing that, and I'm going to show you why. So to show you why, we're going to put another up at the top, which is just a way to show the performance, so how performant, how optimized our patch is. Notice that we also have a way here. You have different options. You also have a profiler for the programmers here to know which op is taking more time, what operation is taking the most time. But just by default, by checking this performance and putting this at the bottom, and I have my frame rate, right? And how many times this spends on the CPU and on the GPU. So far, so good. It's 5 cubes. Now let's try to crank it up, right? To put more cubes. I'm going to repeat. I'm going to put 100 cubes. Right? So now I have 100 cubes being displayed. Okay, 4 milliseconds. So if I'm below 16, I'm good. 1,000 cubes now. So now it's 25 frames. So sometimes, I think it's not very accurate, but it's okay. It's still around 60 FPS, right? For here. Now, if I put 10,000 cubes, I'm not sure if you see how laggy this becomes, right? Even on my computer, it's quite powerful. I have 36 cores and 3 GPUs. It's still it's laggy as hell, right? Because it takes too much time to render for each frame 10,000 cubes like this. Right, so maybe don't try this if you don't have a powerful computer. But so imagine, and 10,000 cubes is nothing for a GPU. But notice that everything here happens on the CPU and nothing on the GPU. The GPU stands for graphic processing unit, and we don't even use it. So what's the point of having one, right? So this is not the right way of doing that. So I'm gonna put less cubes. And for sure, it's why. If you just want to do a line, it doesn't matter. It's 100 or 1,000,000 cube because we don't even see it. It starts to clip. It's too far in the background. But how do we change that? So to change that, we have to use the GPU and not use this naive repeat function that we almost never use, by the way. So I'm disconnected this guy, and we're gonna redo our chain here. But instead of using repeat, we're gonna use another operator, and for that I need to introduce arrays. So instead of having to repeat the same operation the same. It's a bit silly. It's like, go back to 0. Oh, now go back to this particular position, draw a cube, hey, go back to 0. 10,000 times per frame. Insane. Stupid. It would be better if we could just give the position, because we know it's the same shape. It's always going to be a cube, and say, hey, GPU, I'm uploading this cube into your memory, and I'm sending 10,000 position. For each of these positions, put a cube there in one go, in one pass, basically. So how do we do this? Notice that I'm not deleting. I'm just putting this aside. It's not connected to the main loop, and so it doesn't work anymore. But it's here. I'm going to introduce arrays. When you type an array, you have 237 ops related to arrays. So it's really the bread and butter of cables, arrays. And then we have textures, two different stuff that we use in cables most of the time. If I type an array here, by default, it gives me, okay, this is the size of my array. And how do you want the array to be filled? So by default, it's an array of 10 value. And check what I'm doing here. I can click on this class here, or even this previewer. If I click here, I can see it in JSON format like this. If I click on this small tab here, I see it as a, more or less like a column value, but it's not very, it's not Excel, right? And then you have this gearbox that shows you if you want to plug numbers. So it's really better when you want to extract from a hierarchy. You have a JSON object with tons of different properties. You can expose them by just as an array or as a number. But for here, notice that we have 10 zeros. If I say I want to have between 0 and counting, it basically gives me the index of each value here as an array, right? Don't stop me if I'm going too fast. Huh? But now I can start to decide the size of my array, and notice that the array is this light purple, violet, color, and you also have the size here.
But there is no trigger in this one.
Sorry?
There is no trigger.
No, it's you're creating an object, right? So it's there now.
Okay.
It's not being triggered, but it's there. Now I can change the size of my array again. Fine. And notice, so when you go transform, we need two things, right? We need position X, Y, Z, scale, and scale X, Y, and Z actually to change some size of the cube, and the rotation. So in theory, we need 9 values to really control the shape and size of our cubes or our geometry, right? So in theory, it would be 9 arrays, right? 1 for X, 1 for Y, 1 for Z, 1 for scale X, Y, and Z, and rotation X, Y, Z. 9 arrays. It's a bit tedious to do, but I'll show you some shortcuts. By default, if you don't put anything, it assumes that it's going to be 0. So how do we draw stuff? Well, we use another technique that we call a mesh instancer. So mesh is any geometry. So this guy, for it to work, you need things. You need to execute it. You need a geometry, and then you need arrays of position, scale, and rotation, and colors if you want to. So you can have different cubes with different colors, and texture coordinates. But we're not going to cover this now.
Kirell, just a question.
Yes.
Do you know if this video will be recorded and will be?
Yes, it is recorded.
So we will have a link to the video.
Yes.
Okay.
Yes, sure.
Because now I'm spending more time watching your video instead of working on my project.
It's better when you do live workshops, right? That I can go around your screens, but here, if you have a small screen,
next
you can.
Next time in Paris.
So, sorry, I didn't eat, and it's 9, so it's starting to get hungry. We'll do a break after. So, after the arrays, we'll do a small break. This is the bread and butter. Like all 90% of what you see in cables is this guy here. Mesh instances. So you need to execute it. Okay, first, we connected. Fine. Then second input, the geometry. What do you want to instantiate on the GPU, right? So we want our cube. Okay, so I'm going to disconnect this cube here. This cube needs to run. So I'm going to connect my cube, take the geometry of this cube and put it here. Uncheck the render. So I don't need to draw the cube here. I need to use this guy to render. So I'm unchecking the cube, not being done twice. It is not, this is just by default, you have one cube being drawn here. Okay. I'm going to put my orbit controls back to the beginning so that you really see that we have one cube at the center of the screen. Now we know that we also need a material, right? Because otherwise it's blend. So let's put this material, and I know that I need to put it before I draw anything. So here, and now my material is going to be whatever. Oh. Right, and I'm gonna disconnect stuff so you see it better. Okay. So far we didn't do much, right? It's just a more convoluted way to do the same thing. Now, what do we have next? We have scale. So by default, we scale everything to 1. Okay. Limit instances, you don't really care. We want as many as we want. Now, how do we set how many things we want to draw? It depends on the size of the array that we pass to position, scale, and rotation. But as I mentioned, position, we have position X, Y, and Z. But there's only one input for 3 arrays, basically. So how do we do this? Well, in OpenGL and WebGL and other graphic library, you need to basically flatten the array so that the position of the values are like this. X0 for the first cube, Y0, Z0, and then X1, Y1, Z1, X2, Y2. So you need to flatten and have triplets of value. This is how to basically have a more optimized representation and go to the GPU. So I'm going to say that again. We need to basically have the different arrays that we need, and we need to pack them so that they come as triplets. So we have one array here. I'm going to put a comment here and say position X. Okay. Now I want to have so the X is going to count from 0 to 1. Okay. Now position Y. Well, for now we want all the cubes to be on the same line, so they're all going to be Y equals 0. And the number of instances is going to be 10 again. So to make sure that they all sync together, I can just do a number and say number of cubes. Cubes. I'm putting, I don't know, 100 cubes. I'm connecting this to the length of my array here, and notice that I can actually take the length of this guy here, but so it's the same. So that I make sure that I have the same number of points for the position X, position Y, and position Z, right? So I have 3 arrays, and as I mentioned, I need to flatten them so that they are one array of flattened value. And the way to do that is called array pack. Pack 3 individual arrays into a XYZ array, right? So I need to have a trigger so that's doing some kind of optimization and knows whether the array changed, and if it changed, then you basically change it, otherwise you don't. So I'm putting all these 3 arrays here. Trying to do this, whatever. And now I have one array here that is basically a flattened representation. Check it out. 0, 0, 0, then X is 1. Everything stays 0, then X is 2, and then 0, and 3, and 4. Does it make sense?
Yep.
This flattened representation. So I have 100 instances, but the final size is 300 because I have 1 for each position. Then I'm connecting this to my mesh instance. And now I have 100 different cubes here. So it's a bit like before. If I want to change the position between, as I did before, the multiplier to change how far away cubes are, I can do, instead of multiplying by each individual cube, I can just do array multiply and say at the X position, I'm going to multiply it by 0.5, right? So they are going to be closer to each other. And now check it out. So it's a bit more work, but we have now a nice way of doing the operation on the GPU. So let me show it to you. This is the number of cubes. 1,000 cubes. Check my CPU, it's never increasing. 10,000 cubes. 100,000 cubes. It's just 1 millisecond. So I have 100,000 cubes here being drawn. I can go up to 1 million, actually. It's going to be laggy a bit.
That's very impressive.
So now it takes a bit more time. So I have only 30 FPS, but I have a million cube being drawn actually at each frame. So it's a bit too, you're reaching basically the limit of WebGL here. But it's still impressive, 1 million cube being drawn. And you don't see, of course, you don't see the difference between 1,000 and 110 cubes, but it's just to show the difference that nothing really happened on the CPU and we put everything on the GPU. Right? So now we can do the same trick. So this is just about the position, but we have also the scale and rotation. So instead of having to define 3 individual arrays, what I could do for now is just to have a random position, right? So I can do random arrays and say, when you put this node here, it says, okay, how many do you want? So this needs to be the same size as everything. So I'm going to connect this to here. So the same number of instances. And then because we already saw this sidebar, what I'm going to do here is to create another slider for the number of cubes. Right, so I'm going to connect this here. I'm going to call this objects between 1 and 10,000 maybe, 1 by 1, and by default we have 100 cubes. So when I open this, I have this number of object slider, and I'm connecting this guy here to the number of cubes. So when I do this, even it's way too big, but maybe 1,000 maybe. I can change the number of cubes like this. Okay. Now this random array stuff here, it tells you, okay, what is the shape of the output array? This is just a one-dimensional array, and this is the XYZ array, the thing that we need, right? The different triplets. And what is the range of the values you want to draw? So this is going to be our scale. Okay, let's say, so the scale could be, right, if it's 0, it's not being drawn, right? So I can say 0.001 and 2. This is an X, and I can do the same thing for all dimensions, 0, 0, 1, and 2, and 0, 0, 1, and 2. So I'm creating random values between these ranges, and then I'm going to connect this to scale. And now we start to, I think you get the idea. We start to see interesting patterns. We try to actually see interesting patterns because we have randomly assigned a different scale. So the cube can be bigger, fatter, smaller, taller, anything we want. And it creates a variety here. Now, the third array is the rotation. So I'm going to copy this, paste it again, using the size from the number because I want to show that everything is aligned. So this is called scale. And this guy here is going to be rotation. And now, as we said before, rotations is in degree, right? So say between X between 0 and, 90 degree, but for Y is going to be between 20 and, 200 degrees, and Z is going to be between, 10 and 270 degrees, right? And code it and put this into rotation. Right, so now we have random size, position, and rotation, and they are colliding a bit, right? They are in front of each other. So
are we expecting you, Kirell, to at some point converting one of these? I mean, replacing one of these random arrays by your JSON file?
Yes.
Okay, that makes sense.
I mean, because I'll show you how to do this, but I really want to spend some time really so that you get this idea. It's all about basically setting position in space, right?
Yeah.
That's it. That's all there is to. I mean, that's all the difficulty as well, right? But it's about putting stuff in space, creating some links, and here we have all the tools to make the rotation, everything. If I want to color, as I mentioned, you can do also a random array for colors, but the colors, they need actually an array for, because you need to also set the alpha value, right? So I'm going to put this here and say I want to do, and value has to be also between 0 and 1. and because as we saw with the clear color. So if I put this now, I have random value. But notice that the Lambert material is actually it's really one of the worst material there is. If you want to have a more powerful one, you can use the Fong material. And you see that we have more options, and see it's much bigger in size. Can you see that? Like 30 different entries here. But this guy here can take textures, bump maps, I think, to really make it look alive. So I'm gonna delete this, and we don't even need this anymore. But just by default, you have a white, a bit, but you see that it's better actually. It's brighter and it's more real in theory. Now you can also play with the reflection, how shiny the material is or not. If you put some textures, how it reflects light. You can put some diffuse texture. So basically, I'm clicking here, and it creates this texture node. And then I'm going to just click here by default, and it opens the default files that you can upload. And you can upload any image you want here. So let's say I'm going to use the beach texture. And now they're going to be, of course, the texture on top of the color. So it doesn't really look good because it's stretched and everything. But now, so okay, it's not really interesting. Now let's change the texture and try something like this. Yes, in theory, what I'm doing wrong is that I'm not using the right texture. Okay, sorry. So here, if I'm putting this texture, it doesn't really shine through. But first, there's tons of different texture you can use.
You should go on the.
Yeah, you can maybe use the opacity, but it doesn't really work. If you really want to make this work, you have to use another type of material. I want to show you. For instance, the basic material would work, or the matcap material. So let me show this. Remember the basic material, as I say, you can change the color. So by default, we put it to white because we also have random colors being added here. I can put this and basically shape my object like this. All right, so now on the face of each rectangle, I have my texture being colored by the shape. So when it's transparent, it goes back to black. So it creates this kind of weird effect, or you have semi-translucent cubes, right? And you can also play with the opacity here. If I reduce this, then some of them are going to be more as colored by this. So when it's 3D like this, it doesn't look very good. But let me show when I remove the rotations. And if you start to just something like this, you can really, and the cube, instead of drawing all the faces, because we see one on each side, you have the same texture. I can go on my cube, remove the height and say, hey, I just want you to draw the front face here. So I'm disabling the rest. So it's basically going back to having a rectangle, right? But now so it's not a rectangle anymore. This is a texture that we applied, this flare stuff here. And you notice that if I change the texture, even though it's a rectangle, I can really create different looks. Like this is exactly how video games work, by the way. It's always about rectangle when they're far away from the camera. So notice how I'm using just and applying this texture. So now it looks like I have triangles on screen, but they're not, right? They are cubes. Do you get what?
Yeah, one face of the cube.
Only one face of the cube, but with the texture, so now you can let the user change the texture if you want to, and you can, with the same technique, have really different looks, right? Like the dots here, right? Or stripes. We have one. Well, stripe doesn't work. It's just one side of the cube. Black on black, it doesn't. But you see what my point by creating. Now the next part would be, but we can create our own animated texture within Cable. So we can even change the way each cube is going to look. It's going to be slower though, because you have to basically re-upload the geometry each time. But yeah, just to show you how versatile this whole thing is. So instead of having a thing that we define, we can also use the same random array. So are you guys watching me, or are you trying? It's too difficult to follow along, right? I suppose. Or are you still trying to experiment yourself at the same time?
If the question is how we able to redo just what you did, I think the answer is no for all of us.
Right, this is
But
all-
it's very interesting. I guess that I should review what you did actually for 15 minutes and then trying to apply the same in my project.
Yeah, take your time. I mean, there's tons of tutorial of this on the YouTube. They have more like 100 videos on cables on bank doing small operators. I have my own tutorials on YouTube, longer tutorials, how we try to take some data. But I just want to, now we're going to practice. So you can, maybe during the break, you can recreate the same stuff here, the same nodes. But just to give you an idea here. So now everything is between -1 and 1, right? In the position that we used here. So let me do. But this is how you would create the particle. I mean, more like a Star Wars effect stuff, right? You have all the stars. Instead of having rectangles, I put spheres, and I can put them very small, right? So if I do this and I change the.
There is no particle object in this environment?
No, I mean.
No? Okay.
There's a way to do particles with the GPUs, but it's mostly about this, right? I'm creating, because here I can create all the shape. I mean, the particles works like this. It's exactly that. It's a mesh instancer. There's point cloud, and which is just a mesh instancer for points. So it's exactly the same. But here it's more versatile because I can really instantiate the shape that I want. And let me go back to the position, and then I want to be between -2 and 2 in old axis. And recenter my camera, and I don't, maybe remove the texture. So now you see I have this, and if I want to, if I'm too far, I can just put it closer to the camera by putting a transform, or by moving the camera. Let's say I'm going to put the transform here. I'm going to put it closer to me. So by default, when I zoom, I'm inside, or maybe I'm too far. This is the maximum zoom, so I'm going to put this here. Let me show in full screen now, right? I'm inside my artwork.
Can you add lights?
Yes, of course.
Yeah, okay.
Anything you think of in the 3D world, you can do. You just need to have a material that is reactive to the light. So the basic material doesn't react to the light. It's just, but the foam material does. So that's
okay. I don't think it's useful to demo that now.
But you can do this, and what you like a cool thing to do. Imagine that you have a light that is really moving inside, and that's shining on different objects, inside of the sphere like this, and moving, and this kinds of effect that you can create like this, and it's as you see, very easy to do. So we see, it seems that we have a lot of stuff here, but it's really different blocks. So you can also organize your patch with a new block called area here, which is just a way to put things inside. So I'm going to say, I'm going to grab all this. And now this is going to be into, and I'll call this area position, right? Transform. So I'm trying to organize my patch visually in different area. And notice that this is not only about graphics. This is a paradigm shift about how to program, actually.
Yeah.
Because I have this example, and you can check my videos, or I do web scraping. So I extract data from a web page using cables. There's nothing to do with visual stuff. You do machine learning, and I wanted to show you this, how to call an external API after.
Actually, I do music with that kind of things as well on the video.
Yes, you can do this. I have a video. I created a beat machine, and we are trying to integrate web audio, state of the art with sound analysis and generation with AI inside of cables. But we have tons of. If you type audio, you have recorder, analyzer, playback, all the delay stuff. I created an oscillator that is now in cables. We also have the MIDI stuff, so you can control your patch with some sound, or a keyboard, or anything you want. It's really, really versatile. If you want to connect with the server, you have all this WebSocket. But let's make a break. Maybe you guys can try to reproduce this. And
how long do we have? Do we have 20 minutes?
No, 10 minutes. It's just, remove this. Just take the number. Let's say we put this aside. We just put random. You copy paste this random array stuff. You connect to a number of cubes you want, and then you put the values that you want here, and you connect it to the mesh instance. That's all you need. Okay, I'm going to remove this. Just that.
So what we need is the random array and the mesh instance.
4 random arrays, right?
Yeah.
And the mesh instance. So yeah, let's do like a 10-minute. I mean, this is just the 3 of you. I can wait for you, but let's.
Okay, let's try.
Yeah, it's small, right? It's very small. Let's try to do this and make a break, maybe 10 minutes. Then I'll show you after how to play a bit with textures and how to call an external API and basically launch our JSON file that we had. Right.
And that's part 1, because there is a part 2, I guess.
No, today it's part 1 and 2.
Okay, that's 1 and 2.
It's gonna go 3 in the morning. It's gonna be a bit. Yeah.
How long do you think we will stay here? It's almost 10 p.m.
Yeah, so the last hour is supposed to be up to 11. But if we are all, I don't know, where are you guys? I mean, if you're in Europe, it's a bit late. But
yeah, that's okay.
We have 1 more hour. In theory, we had 1 hour and 50 minutes, so I can have more stuff to show you. It's a very small crowd, so it's more like a. Okay. I mean, you know what they say. You can convert 1 people, and then you evangelize and you talk to others. Especially if you come from an engineering background, this could be cool to apply in the company. And for newcomers, this is also a nice way to do to have a shift of paradigm. If you don't have any programming experience, it's also a good way to learn. Actually, a faster way to learn. So just a small experience. I do private tutoring for this for people. And I have a student, 54-year-old, so that no experience in programming whatsoever. And in a few weeks, create very impressive stuff, and now wants to learn how to program. So I say, okay, why not? But with this background, it's coming very quickly because programming is all about moving data and data type and everything. And by having this ID, I think you can really gain months of then learning from scratch, basically.
Yeah, that's paradigm like Code Warriors or all this development, teaching on tutorial for young people how to learn to
exactly. But here, something that I really didn't mention that I should have, sorry, is that if we go on any patch that you see, you can always inspect it. So, right, I'm here, top patches. You like an effect. You like, how do I create the skies here, right? I don't know, they look impressive if it loads, right? So maybe there's sound like that. Okay, I'm gonna open the editor and I'm gonna see and inspect how it was created. So I can get inspired by this. And then maybe I'm gonna copy only this effect, right? So this is why we have this very vibrant community, tight, but really, and we share stuff. So you can, if you don't want to share, you don't, but right, this is something that we did yesterday at the meetup. Someone has an issue how to create an image and put it in 3D, and we just made it on the fly. And if okay, so basically I'm excluding an image in 3D like this. How do you do this? Well, it's pretty simple. You go here and you notice there's going to be 5 nodes, right? 10. So and you like this effect now, and you can steal it, right? And you can even, if you modify it, you're not going to save it, but you can even change live stuff and then copy and paste in your own patch, right?
Yeah.
So this is really, really interesting to learn if you want to go deeper once the workshop is over as well. So let's just, sorry, I'm going to put back this, and it's for, let me a 12-minute break. Is it okay? So we go back at 10 in my time, so in 12 minutes.
Yeah, but it's not really a break, as you want us to do the job.
No, it's sorry. Okay, so you do the job and then we go break. But I think it's going to be not that long, just to copy paste it. So let's take the time you need, and let's say 15 minutes. Is you think it's okay to just copy this and make the break?
Should be.
The rest of you?
Yes.
Okay, but it's okay. I come back in 10 minutes, and you take 15
Okay.
minutes. And if it's we take some time for you guys to have it. No worries. It's a small group. We have time. Okay.
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 All right. So let's see in a few minutes.
Brian, are you still there?
Yeah, but I'm going to probably have to disengage here shortly.
Hey everyone, I'm back. So let me know if you.
It's not working on my side. I believe I did everything the right way.
Okay.
But I don't see anything. So that's kind of difficult to debug, right?
So probably it's this, right? The ranges of your. I mean, you don't see anything on the screen.
No. Just the background changing color. So the same thing at the beginning.
But you have the mesh instancer. But have you checked that probably the positions are? Or should first reset the orbit controls.
I did that already.
Okay, the transform here, is it at 0? So that's not like completely to the left and you don't see anything?
Oh, I don't use the transform anymore.
Okay, well, you don't need to, but so have you tried to unzoom? Maybe you're too far, so you're inside, after the shape. So if you unzoom, you should go back and see.
No.
The position here are randomly set with an array 3, right? This is
yes, ABC from 0 to 10.
So it's going to be to the right, right? All your cubes are going to be really far, right?
Okay, so let's. Okay.
Try and just put the same value, -2 and 2. And for the other, are you there as well? Do you have this issue?
Brian, Julia?
Hopefully they didn't leave, but so let's fix yours, right? So you have -2 and 2. Here's
No, I wasn't for the position. I wasn't -1 to 2. I was from 0 to 10.
It would be put everything to the right, so maybe your camera is here, but you have to rotate it.
Okay, so maybe should I put something like
here the scale is important. Check if you put scale at 0, then that basically doesn't show the shape anymore, right? So
no. The scale is 1 to 10.
1 to 10, so it's huge. So like cubes could be very, very big, right? And your cube here, it's 1 and 1, right? And you can really activate all the faces again. If you deactivate all the faces, then we don't see anything, right?
Okay, so I take only one as the size, okay, for the scale. So for the scale, so I have 1 to 1 for A, B, and C.
Okay.
And rotation doesn't matter, right?
No, neither is the scale. By default, it's 1. You can look. I can disconnect stuff. So you should have just the number of cubes. And the mesh instance and the cube. Did you connect the geometry?
Yes, I did. But I didn't connect it to a sequence afterward. The cube is just connected to the mesh instance. Okay, I don't have the
after
one.
Or before? I mean, before here, right? Something like this.
No. Oh. Do
you need to draw the cube and then connect it to the mesh instance, right?
Yes, I understand the connection between the cube and the mesh, but I don't understand the connection between the cube and the sequence. Do you need it?
No.
Okay, so you can remove this one. Okay, so that's what. Oh, no, you need it.
You need to run the cube at least once. You need to connect it. This cube needs a render.
Really?
Yes.
Why?
So, good point. This cube is actually, you're right. It should be triggered only once in theory because you don't need to update the cube because it's now when you put the geometry, it's fixed, right?
Mm-hmm.
So the correct way to do this would be to use trigger once. So this guy say, hey, it only triggers the cube one time, and then that's it. If you put the flow mode, but you need it once, so at least you create the geometry and you pass it to the mesh.
Okay, got it. Okay, so I need this one.
But if you do this, then it's more optimized. But you cannot really change. If you change the shape of your cube, it doesn't update anymore because this is blocked by this guy here.
Mm-hmm.
So if I connect it back now, this is still live and interactive, so you can create different shapes. It's easier to create this kind of effects, just to test different looks.
Mm-hmm.
But you're right, you can put in the sequence, but you need to connect it. But you can
and the sequence is connected upward to what node? What is the node? Okay, orbit control. Yeah.
right? So is Julia here? Julia and Brian, are you there?
Did they leave?
No, they are still connected, but they are muted. I'm not sure if they came back yet or. Wait, they have chat. Sorry, I need to leave. Okay, so Julia has to go and. Okay. Okay, so we're here, right? Let's continue a bit. I mean, we still have 1 hour. If you want, if you feel like continuing, Patrick.
Yes, sure.
All right. So we're here, right? So now what we could do is to try to load some data.
Maybe if we are just you and me now, we can switch in French, no? Or
no, because it's recorded and people.
Oh yes. Obviously, sorry. Yes. Okay.
So now what we could do is to. I mentioned before that we're gonna use some data, right? So the link that I shared, but any type of data would work. I don't even need to take my dataset. I'm just gonna show you how to actually call or load any type of data. So one thing we could do is to explain the node. The node that does this thing is called the AJAX request, which really stands from the JavaScript API. So for those who listen to us, it's asynchronous XML HTTP request, which basically allows us to load or send data from the patch to somewhere else. So either you put the URL basically as a file, because a file is just about loading something that is hosted on Cables, right? Or you can put even like a JSON file that you would put here as an attachment. So for instance, I have this JSON here that I'm going to put. And so imagine this is an attachment, so a file, a download dataset that you have as a JSON. And I'm going to click here, and we're going to explore this guy. So when I click here, notice it takes the name here on the right. And you can have different options. So by default, it's getting the data from the server and as JSON. And if you check this parse JSON, it automatically assumes that it's JSON and it parses it. So you can inspect the data. So this is actually from the Star Wars API. So this is just an export of one of the value, and you have all the fields as JSON values. And now what we could do is to pluck one of the values that we want. So I'm going to click here on this box, on this gearbox, and now I can say, hey, I want to expose just the name of my. So this is about Star Wars, right? So a name, and this is the last type that we didn't really see. So I'm not sure why it happens in the middle of the screen, but it's the bug. And then we have the new color, this orange color that is just for a string. This is the path where you put in, where you get in your JSON file, and that gives you the value. So this is actually pretty simple to. This is just an attachment, but this could be an URL instead. So instead now, let's go on the Star Wars API. So this is a smaller Star Wars API, and you can, it shows you, right? If you put the Star Wars blah blah API people and /2 or 3, then you get another character on the Star Wars API. So this is really about getting this API and postponing these values. So how do we do this in a neat way? So you notice that this URL here is either a file, but it's just really a string actually. So it's just this one.json. When you click on it, it's just really basically a placeholder for the path on your patch, which is always behind like assets, whatever, like a random string, and then the name. So now we can replace that by a URL. So how we do this, we would do something like this. You would create a string and put the base path, right, like this, without the slash. We can call this root. I can put a comment here, but I can also rename the node, which I don't necessarily recommend, because if you do that, then it means that from someone that opens your patch, you don't really know what is the type. What does this node do? Is it a custom operator? No.
Mm-hmm.
So it's better to just leave it as a string, but put the root the comment here. Okay. Now we know that we have different APIs. We have people, we have planets, and we have starships, right?
Mm-hmm.
So what we could do is put another string. Let's say strong string, and we're gonna call this planet. So we just basically planets with an S. We're gonna compose the URL, right? So if we do this, now what we want to do is to use this operator called string compose, which basically has several inputs, and then you basically define a string with placeholders, and depending on the input, it basically replaces. So this $A is going to be replaced by this string, $B by this one, and so forth. So if you want to create compose this URL like this, you can say, I want to put my first input $A, which is going to be, $A, which is going to be the first string.
Is it a regex or?
No, it's not. It's really simple replace, right? Just dollar with the name, right? So $B, and then it's going to be this one here, like the planets. And now I'm putting the slash here, right? So I'm composing the URL. I can see like the final result. And now, because I want to like request different planets or different people, right? Then it would be nice to add a bit more to our sidebar so that people can, do this on the fly, right? So exactly, I'm going to copy paste this slider. I'm going to put it anywhere I want, and rename this guy and call it, planets. 1 to 10. We don't really care, right? So my default value is going to be 1 up. And I'm using once again. So notice that this slider here is a number. And this is a string. So I need to transform this so that it's basically casted as a string. So I can do a number to string. It's really, if you know how to program, this comes naturally, right? It's a bit what you would expect, the name. So it comes with the habits for those who are not familiar with this and watching us at home. It's going to come with the habits. So $C, and now check it out. I have this API, and then this will change in real time, right? And you can actually see, you see on your screen, the cable is lighting up as I move the slider, right? So now I've created this dynamic URL basically, and I can connect this to the first input. So I'm replacing the one.json with an actual string. And now if I go here, and I'm going to inspect my object again, because now it's not people anymore, it's about planets. I'm going to go here. And let's say, again, I'm looking for the diameter. Okay? So I'm going to take this. And then, so a string is not correct, right? So by default, there's a string here, but it's not, what I want is a number. Because I know that there's going to be a number, it's a diameter, right? So what I could do is say, this JSON object is here. So I can go in the URL, the API, of Cables, and say object get number, for instance. I know it's going to be a number, so I'm connecting my data, and I know that the key to fetch my object is diameter, right?
How do you know? How do you know the peak one was the good one?
Sorry, which?
How do you know in your AJAX request?
Yes. You
took the bottom left connector.
Yeah, it's because it's the object. This one,
Oh, okay, that's the object. Okay.
So either sometimes it's not necessary. If you uncheck this because an AJAX request can be anything, right? It could be you can load a CSV file or anything. Yeah. So if you uncheck, then you have the response as a string, and we're going to use that to query an base64 image. So we're going to get an image like this. But I know that this is an object. I know that these are all the fields of my object. Now I want to pick just the diameter, right? So I know it's a number. So I'm going to get number, the key diameter, and I get, this one tells me if I found it or not, and I get this number. So why I'm saying that? Because now we could, in this, silly, right? But we could map this size and replace the cube by a sphere. So we have spheres, but let's imagine that we have just one sphere. And I can basically change the size. So and call this API. So I would change my whole patch with this API and check how easy it is to change, right? I'm just taking the sphere here, connecting, and put it here instead. Now I'm reducing the radius, and I can basically also reduce the complexity of my sphere. So this tells us how many, there's no sphere in 3D, it doesn't exist. Right? So by it's just trying, I can put 8 multiple of 2, right? And it doesn't change visually, but I reduced and you can see it right inside. I've reduced the number of slices inside of my sphere because they are not opaque. You can see it through actually, which is not good. But I can change my opacity probably here and put everything to 1, and you would not see the inside anymore. Right? So I'm instancing spheres, and I can say, hey, depending on the size of our diameter, I'm mapping this. So I have no idea how the ranges of value, but I'm gonna show you another operator that is pretty cool. Is when you need to change range. Let's say I have a value between 0 and 10, and I need to map it between 255 and 1 million. Right? Instead of doing all the math by hand, which could be tedious, we can use this operator, a very handy operator called map range. Right? Map range says, okay, the input value that I get. I don't know, it's going to be between 0 and 1 million. And now in the final value, I'm going to remap this. It's not 1 million. This is 1 million, right? I'm going to map this into, I don't know, between 0. Because it's in meter, right? 0.1 and 1. So depending on the value that I get, I'm going to create this mapping. So I know that from the size, this amounts to 0.20. So now I'm going to put this to my radius. So if I change the planet here, it's going to call the Star Wars API, get the diameter, and change now the value according to this API, all at once, right? So if this is a small value, and when it goes so small that it's going to reach basically the minimum, so we don't even see the difference. But let's say that the minimum is going to be.
But just to make sure I understand what you do, you selected three planets, right?
No, the planet
in
3.
This case, okay. So you selected 3 planets. So from the JSON API, you receive 3 different diameters.
No. This is the planet ID.
Oh, that's the planet ID. Okay. Okay. Now I understand.
It's not a good. You're right. Planet
ID.
It's not a good name, right? It's not like you're right. It's not. The API just gives me one value.
Okay.
What I could do is to store and recreate my array, and then have an array of diameters, right? I could do this. And this would be actually a good case for the repeat, right? Because it's a small loop. Make a repeat, get the value, store it into an array, and use this array to map 3 planets at once. Does it make sense?
Yes, because the repeat, you will have the index of the repeat, so you can use this index as the index of the array.
Yes, as the here, right? Like this. Exactly. I could use this instead of the slider, for instance. Okay. So, as you can see, it's quite easy actually to make any kind of request. Right? Just one node, and it does it, and then you get the result. So this is asynchronous, right? And when you get the result, then because everything is reactive, if you know reactive programming, it's updating and triggers the cascade of updating values, then it's fine, right? So this is how easy it is to call any API. So this is a JSON API, but it could be a machine learning API that would give you. So I can show another example while we're here of something that I did that is relevant. So it's live here. So just to show, maybe we go here. Let's say that I want to download my so I can create backups, manual backups, and I can export. And I can say, I want to download everything as an archive, as a zip file. I can also sync with my GitHub repository automatically, or host it on Netlify. So I'm sure you know. Netlify is a host. It's like it's a platform to host like server services and static website, and it's free for small usage, of course.
Okay.
And you can deploy. You can also use GitHub Actions to create an executable file. So it will basically wrap your patch into an Electron. So it's a Chrome embedded Chromium browser, so that you can put this into a museum. Right? It's deploying the whole thing. You can embed this as an iframe in any other website you want. And you can also use the command line so to download your patch and do some operations. So it's pretty versatile and easy to export stuff also, and necessarily be able to host it in Cables, right? So still have a number of objects that we can reuse. What did I want? Yeah, I wanted to show you this API, this program that I did, which is pretty cool. And it basically allows you to, so I work in the machine learning lab, and we do pose detection and estimation. So you can send an image here, upload any kind of image, and you will try to find the different key points. And you notice that this is a static image, but on top of the image, I draw and I call an API to get this. It also works with the video that you upload. So if I do this, so it's very simple, right? But I have this dance video or any other type of video, and you can play it. So you even have the sound. And just to show you, you can select I don't know, subjects ID, some kind of the joints. I'm gonna scroll in the video, and right, you have like this sound, right? And you notice that the shadows sometimes right? So the pretty cool thing is that you can do this now. You can see the traces over time. So it allows us, everything here is made in Cables. So it's not only about creating, motion graphics or art. You can reuse this framework to create demos for your project, machine learning, graph, whatever. It's really just a framework and a way of thinking than just something for art. So yeah, you have the sidebar, you have the echo. Wait, I'm gonna mute.
But just to make sure, you mean that the sidebar and all the stuff are done with?
Yes, exactly this.
With Cables?
Yes, everything here is. I can show you the patch. Let me show you how a real. So we have an echo in the stream. If you listen to us, can you mute yourself if you don't talk, please? Someone is outside, right? So let me show you my patches. I have tons of them. I'll show you this after. It was also pretty cool. So as an app, right? Not as an art piece. Wait, this one here. So if you want to see what this project looks like for real, now be ready. So it looks like this. So it's not that crazy. It's different, right? It's not you don't have files anymore like programming, but this you see.
I think there's too much information, so I don't really see because of the resolution. Okay, now I see. Yeah.
Right, I'm zooming. Right, this is my sidebar. Exactly what you see with the different tabs. And now I have what happens when you upload a single image. This is my main loop. This is the WebSocket because I can stream, so I have the webcam and I can basically do this, right? I can stream stuff in real time.
Okay.
So this is how what happens. It's a bit more complex, right? Of course, I have my own ops to do some things, but just to show you, I mean, it's exactly as if you were to program stuff.
Your own ops, meaning that you develop your own
blocks. Exactly, right? I create my own code
with JavaScript.
It's just here. I'll show you, right? So I'll show you just after. Let me just go through this, and just to show what a real app could look like. So it's not an art piece, but it shows getting back the data from the server that gives me the joints, and then I'm drawing the points, and then the joints, drawing the skeleton. So something that this was not in Cables, right? So this code here I did myself to parse and read the data and everything, but as you would in a regular development project, right?
Okay. But in this case, the kind of ops you can add within your mesh is written in what language?
It's JavaScript. It's everything JavaScript.
Okay.
It's pure JavaScript, but there's a way also to run Python in the web using WebAssembly, and I made a video about this. So I can actually write Python code, valid Python code with packages, NumPy, SciPy, all the scientific packages, and run it in Cables natively. So I made a video, so it's really like a tech demo, but it actually works. Yeah, this is just to show you from afar it looks, but it's not. I like the idea that you can group ops and just annotate stuff.
Yeah.
And then I think you can all collaborate on the patch. So it's not as good as Google Docs for sure, but you can still have several people interacting with the patch at the same time, but also, share the patch. If you go here, patch settings, then you can go on the collaboration tab and add another, people, right? And then you can access the patch, access the code, and co-develop the project.
Yeah,
basically.
and how do you deal with versioning?
So, good question. By default, you have auto backups, and you can create your own, backups.
Okay,
So
but there is no Git.
So it is, but it's hidden. Basically, when each time you do a backup, it really creates a copy of your patch. And what I do for a real project is that this is synchronized with my GitHub. So this is why I use the CLI stuff. And when I said here, I'm using the command line stuff from my computer to sync the patch. So I'm downloading the latest version of the patch, and then I'm committing it to Git. But I could just have used this GitHub stuff automatically also.
Yes, but the point is Git sees the file as binary, right?
No. It's
No?
This is a JSON file actually that describes the patch.
Okay, so you can see the
it's
variation.
Yes, you can. But the thing is, without the editor, it's impossible to read, right? But I can maybe show it to you. So there's the Cables doc actually. Here, if you can have any issues, this is where we all the bugs, and then we can report. But let me show you this. So this is public, and there's no problem. This is our lab. Just to show you, if I can find it. Yes, this here. Right. So this is the patch. I have some Python, obviously, to create the server and everything. But this cable stuff here. This is it's synchronized. So this is basically how the patch is described. It's a big JSON file that describes all the ops, where they are, their individual ID, and when they are in the patch. So this is a patch basically. So it's very easy to create a structure and just replace. You can even, in theory, replace the patch on the fly, right? So that you create a website, and because it's just about a JSON file that describes all the relation between all the ops, basically. Right? And you have, and then you can track this in Git, right? With all the history of this. So each time I synchronize the patch, whatever, like here, you see that it's going to change some of the cables file and the ops, right? So all the difference between the ops. So you can see them, but it's a bit tedious. But the code that you write, it's real code, right? So you can see that what happened, right? So you can see I updated this. This up was. So you see, we still have the good sides of versioning and everything, but it's
without the visual interface.
Yeah.
Okay.
Right. But you can always restore. Right. So you can go here and say, click here, and it will restore the patch at that particular point in time. Yeah,
and you can branch and that kind of thing as well, I guess. Are you part of the Cables?
I'm not part of the Cables team, but I'm very, very close. So I have access to the source code. And
where are they?
They are in Berlin. It's a Berlin.
Okay, it's a German.
It's a German team. They are all over Germany, and you have tons of people coming from different backgrounds. We have people now coming from the crypto art, right? Trying to do interactive pieces that creates NFTs and everything. It's not really the cup of tea of the team, but people do this. We have people that comes from more like the motion graphics. Some people for digital art. And what I mentioned before is that you can also do data visualization. So I'm just showing you this public example here. So the point here is that each point that you see is a result on Google. So we basically create a map where you see all what happens when we type your name basically on Google, right? All the results in the different Google organic, news, Scholar, whatever. And we can use that as a way also to create a custom visualization, as you can see here, but with keeping this idea of experimenting with the shape. This is what I really like. So here it seems that we have the circle packing, but also in individual branches. But we can move and also play with the visual properties. Something that would be quite tedious to do in other frameworks, right? So we can really customize tons of stuff like this. Keep it interactive, embedded. I really like this idea. If you want to develop a custom dashboard or visual, right? You can really be creative and still have this idea, or you can click on stuff. And you see that here I mix both a 3D scene plus some HTML overlay, right? That you can see. I'm loading Twitter, I'm loading HTML, and I can mix both without any issues. Basically, it's really cool. So if you come from a web developing background, you can also develop your. I actually made a patch and I had integrated the Bootstrap framework, so you can have components and basically make a website. So using that instead of React, or of course it's going to be difficult because if the team is not trained, it's going to take some time. But it's just to show that we cannot necessarily limit this to just nice WebGL stuff. You can really create any kind of app, basically.
Kirell?
Yes.
That's fascinating, interacting with that video in the way that was working. Presumably, I guess it's analyzing the video in real time.
Yes. Yes.
Can this be used to build like a 3D world, like with all the excitement around the
metaverse or something?
Metaverse. With the new iPhones, you can create these USDZ files with LiDAR. So you can have a virtual world essentially that you can email to yourself, and it's fascinating on a phone. I'm wondering if I could import something like that into this and do some similar kind of real-time analysis or simulation or.
You would have an issue with the. I mean, in theory, of course, right? But the real-time component of this with the LiDAR and displaying it in the scene could be problematic. But for instance, you can load point clouds. It's very easy to load any. I can show you here.
Because being able to three-dimensional that interface that you just showed is fascinating, because more and more interfaces are going to be moving into more three-dimensional. Yeah. And this seems like a platform that could potentially lend itself for building those kinds of interfaces. Even the dome, in the planet, in the sphere you were talking about, is a step in that direction of being able to be much more three-dimensional with your interface.
Exactly. I mean, this is why it's what I do, right? And it's what we try to build with Cables. It's really like a new platform to build interactive experience that work on the web, but also, as I mentioned, offline, because you can download this, interact with anything. So yeah, to me, this is really an underappreciated tool. That's why I do all my workshop with this, because I didn't find that there's nothing else. There's a node-based visual programming offline. One would be Touch Designer. It's a paid tool, older tool that works like this. It's not the same interface, but it's work like this. This is what people use to drive lasers and big interactive shows. But you have to download, you have to pay, and you cannot distribute. What I like about this is you create a website basically, so that you can run anywhere. Actually, I tried to make it run on the Apple Watch. The patch itself didn't really work, but it was actually loading, right? So even like the patch you could create, I used it for your phone, and with as Google, Amazon, everything, and all the FANG try to put more resources into making the web more powerful, accessing a Bluetooth API, GPU, web GPU is coming, WebAssembly and so forth. You can really, it's not about only the web HTML anymore. It's really creating experiences that you can distribute to anyone. That's the whole point, right? So I mean, to me, it's the best framework. Just to showcase our algorithm. So Google usually works with, I mean, we have a different approach, but we are very competitive. I mean, it's state of the art in not very far. We do multiple, live people. Usually MediaPipe, the other algorithm, they focus on one subject, And here I'm showing you it's running and sending on the server, but you analyze tons of people at once. So we can analyze crowds, and it's completely anonymous because we don't care about the image. It's not even stored. It's just the silhouette. And this is basically the basis of what we could use for autonomous vehicle. So we not only people, but also, dogs, because, you have to stop, right? Animals and everything. So we have different models that you can play with. We can also have one for cars, where you detect, I'm not sure if I have a car image, but I can try. So this is like animal hands and, fast car, accurate car. I can try to find it for you. But this kind of interface are really powerful. I'm not sure if you see my screen. I'm looking for a car image, which I don't find, but and I want to show you something else. So I don't find the car. Sorry. What I can do is to show you other amazing examples. So for data visualization, let's say, here we are creating basically everything from scratch because we want to have the control over everything we design to create our graphics or piece or whatever. But there's also, if you want to use this pre-made charts, you can. And I made a YouTube video about this, so I will not go over everything here. But just to show you, maybe you're not familiar with this. This to me, the best visualization library out there, which is called eCharts. It was developed by Baidu, and now it's Apache, right? So it's free, open source, whatever. You can use it anywhere. These are all the charts that are basically included. So hundreds of different charts. I'm not kidding, hundreds. And each time you click, this bar race, something that we saw everywhere. Notice that to create this, there's no code involved. It's just basically, you can have some code, but it's just a big description, JSON object that describes how to how to draw each axis and everything. Of course, there's a function here because you make it interact, but this is wrapped directly in Cable. So you can copy paste most of the code here and it would work in Cables. So
because this code is also written in JavaScript.
Yes, it is a JavaScript. This is like a JSON object or a JavaScript. So JSON, like serialized JSON object or a JavaScript that describes what happens here on the right. So you can take any example, I don't know, a smooth line chart. Okay, so and notice that this is you have nice legends, interaction. You can click, you can highlight. You have different themes, everything, and it's just about having this object that you pass if you load the library. And this now is in Cables. This is just one node that I created, but that's available for everyone. This is called eCharts, right? So you put this eCharts, and you just set the options. So the code that you get from here, right? You copy, you paste it as a string, and it should work, right? So you can do a string editor.
Meaning that the connectors will adapt depending on the kind of chart you're using?
Sorry, you can say again?
The eChart, the main parameter.
That's the cool thing. The node here is a eCharts node that can take any of the description files that generates the 100 different charts.
Yes.
So that you only need one node to create all of this. It doesn't change.
Yeah, I got it. The point is, how do you send the parameters? Because depending on the kind of chart you are dealing with, you need specific parameters.
Of course, that's you need to. I mean, the chart doesn't exist. I mean, you still need to specify the data and everything, right? But so you send this object, but you need to construct it somehow. So what you can do is copy, paste, and just replace values with the new data that you get.
Okay.
Right. But just to show you, this is really not trivial to do by hand. Having this kind of two slider with the that change, that annotates, or you can click and everything. But I mean, let's say I love this library, but each time you want to make a chart, you have to really copy paste, create a new website and everything. It's quite tedious. Mm-hmm. Instead, here you can just go. Let's take the most simple example here, and you copy the option and paste it basically in the node, in the eCharts node here. So this is the chart object. So you can do. Let me show you. So I'm going to do the parse object, which transforms a string, a JSON string to a real JavaScript object. So I can do this. I just need this. Right? This is the object that describes the whole thing. And yeah, if you want it to be correct, you actually need to put the JSON as this, right, with the quotes.
Double quote, yeah.
So it's tedious to do, but I can show you. So, and now if I wanted to change the data, well, I can, with the you know, I show you object get number, but you can do object set number or set array. So I can change this value dynamically, for sure. And have a way to describe my file. There's a quicker way, by the way, as if you can do this by hand, to really load the JavaScript object and not a string. But I wanted to show, imagine that this is actually streamed from a server somewhere. It means that you could have create this kind of placeholder that would, you need double quotes. That's a shame. But I can open the example that I already did. Maybe it's simpler. So it means that you can have dynamic charts that is streamed from a server, and you just create a placeholder that does it automatically for you, right? So there's tons of possibility that would be quite difficult to do, for instance, with D3, the main JavaScript library.
Mm-hmm.
You could not really do this. So yeah.
Can you just put in the conversation pan the URL of the charts?
Yeah. So this is Let me show this example. eCharts is this guy here. It's my favorite to go, the best library I know for this kind of stuff. And so as I mentioned, you have this chart configuration object with double quotes this time. And automatic. So I made it's very simple. You can capture the events. So let's say I want to on click and do something, for instance. Or on click on but on one particular bar and not the other. I'm counting here how many times I've triggered, and then I'm back in the cables world. So I mix this other library, and then I can use it to drive a 3D scene, right? And the method. So you can have a 3D world, or you have charts, and then when you click on them, it triggers a 3D, animation or anything. So this is and this is completely, of course, responsive and everything. So just want this, for instance, to get the size of the canvas, to make sure that this refreshes automatically. And now if I want to change the size of the bar, I don't know, I put it to 200. I save this, and then I'm going to have an animation. And you see it's smooth, animated, and everything.
Do they have any connector for BI tools like Tableau or Business Objects? Or?
So, no. One reason is that usually the API key, you cannot give it on the client side, right? So, and you need to have a public API. But it's, as I mentioned, it's really easy to do any connector. So for instance, I would be open to create one for you, right? If you need one. But as I mentioned before, I wanted to show you how easy it is to create an op, right? So let's say you want to create your own connector. So I'm going back to our, so this is a bit more advanced, but I mean, everyone.
That's part 3.
Yeah, it's part 3 or 2. But okay, you have this developing the background. So what you can do is create an op that is shared, that you can use on all your patches, or you can use an op that is only available in this patch, because it's really related to this particular project. So when you do a custom op, this is basically, so you put this op here and then say, okay, you can load the library, any library you want from the web, or you can edit as a JavaScript. So there's a whole documentation. Of course, it's not out of my hat, right? I'm not. So basically what we need to do is to define the inputs and outputs, right? All the ops work like this. And if you don't really sure how to do this, well, you can open any op, view the code, and understand that, to create an op, I need to, if I want to have a floating point as an entry, I can do this. You can say that, right?
Also, the code of every op site is available, actually.
Yes.
You can do everything.
Check this. Like, as I'm saving, I'm going to create a new port. Right? So it's really simple, actually. Now, And now the only thing you need to do is what happens when this port changes. So you basically could, when this value changes, I'm clicking here. If I move my mouse, what happens? So I need to say, when this value changes, I'm going to create, I don't know, another function. And with the value, I mean, so it's v already, which is not a good name. Let's call it value. And this guy here, so I'm taking the value. And okay, for those who don't know this, you can also do, let's do this cleanly, sorry. So we're gonna do this function. We call this change value. We call this v to be the input value, and I mean, sorry, it doesn't take any argument. And so how do you, so the how do you get the inside? So here we basically create a port, and if you want to get the value inside, you just type the port. So in value is the name. It's not a good name, and because this value 3 times. So
yeah.
My
input or
my float, right? So that to make sure that it's very clear, and you use get, and then we'll actually give you now the actual value that is passed either by the mouse here or connected here. I can print it. What I could do in our case, we're gonna take the value, multiply by 4, and we return that, right? So if we do this, then it's not really gonna be set as the output. So I need to create also an output port, right? So I'm going to out v, and now you do this out number. This is strings that I can create. And then I'm saying the way to set the value is to just use the name of the port and set.
Isn't it double cut for output?
No, it doesn't matter. JavaScript can use both, right? And now I create this output. Check it out. So now I'm saying, when take my input, whatever you put as input, and I'm multiplying by 4. And I have it.
Yeah.
So it can be any, so it's like the simplest op you can do, right? But it works like this. And you can wrap any API, HTML API, you can load libraries, you can, so you're not, this is exactly what I did. So in the eCharts, right, I created the ops that loads this library, that created my own basically functions to refresh when you change the options and everything. I also, I did this with Python. Can you write Python? You have a video on this. Create the oscillators. Now I wanted to show you this. I think could be of interest if you come from the data viz world. Something interesting that I did was to take a regular D3, tree map, right? Something that it creates this kind of visual, but try to make it so that it works in 3D now. So I don't know why my watch is crazy, but sorry about this. It's acting up. So this is a tree map, right? But now you can map, instead of having in 2D, why not use the 3D? Because the cubes here don't really need to change, but I can now push them, right? So I can create very interesting shape that I never seen before, like 3D tree map like this. Play with the padding. So I'm just wrapping the D3 library, but then I'm playing with the materials and giving some depth for rotating stuff. Also allowing you to have different layers of complexity, or only put in one or the other, and so forth. So we have this very cool now tree map that comes from an existing library, but then that I created as blocks that you can reuse in other projects. So what I like about this is that you spend some time creating your own blocks, but then it works for all the projects you need. You just need to compose them. So this is the tree map that I use. And then I'm using some blocks, and I can reuse in any of my projects. Something that is quite difficult to do actually in regular JavaScript projects, because we don't have web components yet. They're not self-packaged components, right? But here in this case, they are, right? So you can create micro APIs that you reuse in other parts of your code base. Does it make sense?
Yeah, that makes sense. That's really a great product. Very impressive. I never heard about that. That's kind of
and it's free, right?
Yeah.
So the editor is not open source yet, but they plan on doing this because it's still in beta. What I mean beta is that, I mean, every week we add new stuff. And if you say it's 1.0, then you need to start, to take care of the previous ops. But they actually have a nice way of doing that. So when they update an op, usually have version 1, 2, 3, 4. So it doesn't break any of your patches, but then you have a way to just click and say upgrade the op if it's old. So because we don't want to break, of course, your projects. So I can hopefully show you more stuff, but it's infinite, right? What you can do, wrap any libraries. This is the example when you control the patch with your phone, so that you use the accelerometer from your phone, send the coordinates using WebSockets, and get them back in the patch and control them. And
do you have any what website or what library would you recommend for AI entry point to connect to cables? For instance, the one you use for the mesh on the picture.
You mean like a tutorial on doing AI with cables, right? Or
No. I meant entry point for AI, for image analysis, for instance.
In general, you mean like okay, but for art or just AI in general?
Yeah, no, art.
Okay, so there is this website called Creative Artist, I think, or something like this. No, it's not this for sure. I can't find this. Is it this? There's a website, or there's like 41 tools, AI tools for AI.
Because I'm expecting you to use that kind of website, right?
Yes and no. I use my own. I have all the GPUs I need, so I use my own models as well. I can download the.
Okay.
But this is what I want you to. I'm gonna put the link in the chat as well. With cables it would make sense because you want to call these APIs to do stuff. So for instance, this is another workshop that I run. It's called Introduction to AI Art. We use this platform called Runway ML. I wanted to quickly show it to you because of interest. And when you log in, you also have tons of models that are being hosted, like this, right? They work with APIs. So they run the GPU and their servers. So you pay for this. You have free credits, but then you pay. But you can create your own model and have it hosted. So for instance, here, I have this SkyGAN model, which is generate image, random clouds, basically, because it's an AI model trained on clouds.
Okay. And
this website here automatically creates an URL. You can have public or just private. And then it really wraps it creates the server, API, and everything. So that's very, very convenient to just have it in cables and call the API. So and say get image, if it's the right URL. So I'm going to check just to make sure that it's loaded. Then it calls the server. So let me, I'm taking this URL here. And I'm just putting exactly what I showed you right here, right? Putting the URL of the model. And then it needs to start somehow because the URL is cold. So you don't pay basically when no one is using it. When you do this, they stop the model if you didn't use it for the past hour or something. So then you need just to wait a bit so that it starts and it boots. Basically, it's ready to use. And then you have an API on the fly using GPU. So it's very convenient to test stuff with this. You see, it's still waking up.
And you can freely host 3 different models, right?
I mean, if you pay as much as you want, but
but if you don't, you just have
one.
3.
One.
One. Okay, one.
It's one. And if you go in models, if you go here on community or experimental, it's really nice because, You have this model. I want to have detection. I want to use deep dream and everything, and then you can wrap any of these APIs very with just a sidebar and the AJAX request that I showed, and then you can make very interesting experiences like this. So when it's ready, and it should be green. Yes, so it's green now. If I get the image somehow, I think it's this. I'm going quickly, right? But I think it's query at the end. Yeah, I mean, I was not ready to show it to you, but I mean, usually it works. Yes.
Okay.
Right. So now I'm calling the API. Now it's faster when it's booted. So I just changed the seed value. Click get image. It's calling the API. Now I get a new sky. Right. And so it's simple, right? It's just a sidebar. An AJAX request where I create the object that it needs. And I'm creating this texture. So this is something that we didn't really cover. Basically, I'm pasting this. I'm drawing this texture that I get from Base64 to this draw image, and I'm adding an effect. So by doing this image compose, it's really like creating layers in Photoshop, right? So and I can add any type of effect. Let's say I want to add the plasma effect, any shader effect. So now I'm going to add the plasma effect on top of this, but I'm going to lower the opacity, right? And, I don't know, change the blend mode. And now, okay, I like the plasma, but it doesn't really move. So what I could do is to also add a timer, as we saw before, and just put this in time. So now I have a moving plasma effect, right? So I'm composing effects and creating basically the resulting texture that I'm applying to my rectangle. Exactly as we did before with the beach image, but just this
rectangle is 2D in this case.
Yeah, because it's just a plane.
Yeah, obviously.
Yeah, I could try. I mean, I don't know what it's gonna. I mean, it's gonna stretch everything, but I don't know. Right?
Yeah.
I could do this. I want stretching the texture, but yeah, I like how easy it is to experiment. I don't need to disconnect. To do stuff. This would be, I mean, imagine coding this. It's tedious, right? You need to code.
I do agree. Yeah, as long as you are in the creating process, it looks very easy, kind of easy. I'm more concerned by the debugging side. I mean, if for any reason it doesn't work, could be tedious to debug. No?
Yes, but I mean, it's still, if something is failing, I mean, it's really like a console, and you can. Yeah, I agree. It's not as it's not as powerful as having a debugger, but you also have this profiler, and you have with the flow mode. If something doesn't work, you can really see where it fails, and also if the op is failing, it will be red. So you still see where it doesn't work. I'm not saying that it's all roses, but this guy is gonna be red, and it's gonna be like I don't know, fail, error, blah blah blah, and you're gonna see in the console where it happens actually. And if you have very big patch, you can also open this, find all the ops, warnings, this and with errors like this. Imagine you have because they have patches and 6,000 ops, right? And you want to quickly go and found unconnected ops, and then I'm going here, and so you can really go quickly into your patch. You don't need to be like this and find the op again, right? So they have some tools to make it work. Yeah. So I'm going back to conclude. So for those who work at home and see this video after, and for you, Patrick, and all the rest, thank you very much for attending. I know it was a bit late, so we don't have that many people. I would strongly encourage you, if you like this presentation, to go on my YouTube channel. I'm doing a self-promotion here, but it's really about cables. So you can also see techniques to run Python, e-charts, making a beat, whatever, web scraping, and also the Cables.gl channel, or the Cable official channel.
Could you put that in the chat, that website?
So everything is in the... When you go on Cables, if you go back to the main page, you all have this learn stuff. You have all the documentation and all the video tutorials. So you have the Cables channel, and I'm going to put this as well here. Right, so they have also, like, demos, right? So it's grouped by tutorials and everything, but they also have they come from the demo scene. So this is like a thing that they do for contests, or it's something that started in the 90s, right? It's also related to the electronic scene and everything. So this is their background. I'm more coming from a data visualization background, but just to show you what you can do with this more artistic, I would say, and interactive, right? And by the way, I didn't mention, but you can now also record your patch. So you can create a video of you interacting with your patch from within Cables and download the video and upload it on YouTube. Mm-hmm. This. And so yeah, you can go a bit further. And also, I mean, if you want to do more in-depth tutorial, you can always reach out to me and can narrate something. And I think we covered all your questions, but otherwise don't hesitate to ping me on LinkedIn or Twitter if you want to continue a Cables journey or data art journey in general.
Thank you so much, Kirell.
Yeah, I hope that was not too much. I know we started easy and then showing you more, but it's just an initiation. So I hope that you see the realm of possibilities and that you feel motivated to investigate on your own.
Yes, I really did. But I wasn't expected something so with so much material, and that's part 1, 2, and a bit of part 3 actually. That's
you asked some questions I had to answer.
I do, I do agree.
And so I mean, yeah, you can. I mean, we can do tutorial. I mean, once again, on the YouTube channel, I have like a 40-minute video just on changing the background according to the weather, for instance. So it's slow, but it still teaches some data visualization principles, how this column map that I mentioned at the beginning and everything. Yeah. So it's slow and you can really go at your pace. On the cable side, they really have like 7-minute video on one operator. How do you use AJAX requests? Different operators. And I think you have tons of material to dig.
The great point here is that that was for 4 hours. And you really showed what we can do with this tool and how it is related to data, not just to graphical stuff, but you can also take information coming from various sources, and that's
APIs. And I didn't mention, but if you drag and drop a CSV file, it would convert it to JSON so that you can click it but I'm showing that in the videos actually from the Python, which is I think underappreciated because I spent some time doing it. But it's really quick. Think about this: I'm loading and I'm writing Python code inside of Cables, and it's really run natively by the browser. It's insane. So it's a bit long because you have to load the environment, the 70 megabyte Python interpreter. But it's really Python that you write. So if you are a bit scared of doing JavaScript and everything, you can still use the specified place that I mentioned is here, and I'm running some Python code here with CSV, pandas, and everything inside of Cables, and it's gonna run. So yeah, there's tons of thing. And I have one question from Brian: can Cables be used effectively for exploring and interacting with large, complex graphs? What is the best tool you have seen for this? Yes. So I'm actually working on the one now, the network renderer from within Cables, and I hope that I will be able to share it with you soon. So it's not ready here; it's in the here. It's in the force. So we are using the force graph from D3, but using it in 3D. And hopefully, when this will be ready, it will be pretty cool. But I mean, it's really developed right now, so it's not going to work really well. But and for what the best tool you have seen, it's from what I've seen, it's always custom made, because the best easy to use library would be Sigma.js, right? If you want to have a graph library on the web, it's a JavaScript program that you can play with, and it's nice and it's fast, but you don't have much control about how you really want to replace this by 3D objects and have some effects. You need to go back to Cables and play with if you really want to custom made and have something beautiful like the planetarium that I show, right? You cannot do this by default. But hopefully I will work on creating blocks, and we are actually doing this like force simulation, so you can put any array of position as input, and then it acts as if we were a graph. So that instead of having position for nodes, then it could be positioned for 3D objects or squares or rectangles, and it would still move. So this is why I want to create the low-level tool so that we can use and use in other projects. But it will always be custom made, I would say.
Do they have interactive abilities to like enter information into a dialog box?
Inside here, here you mean?
Well, not there, but even within Cables, so that you could actually input information into a graph, into a knowledge graph?
No, I mean, we can do it for sure. It's not that hard, but it's not built in. No, there's not much in the graph network community, but it's not that difficult because, as you saw, you have this sidebar. So it's any, you want to create a div element. So you need to code a bit, right? But if people know how to code, then you can create any HTML, attach it here, and
like a pop-up dialog box that could be used to interact with it or to update data.
Yeah, we could do this for sure. I mean, it's not built in, but it's not that. Look, I'm just doing this div element, and then it's here. I can change I can put the style. My anywhere I want, and hide it and have it only visible when I use the input data, right? Write some stuff and then add it to the data. So it's not built in, but it's not that hard to make. Mm-hmm. Here. Yeah, they also have a tutorial on div elements. I have a demo where we rewrite bootstrap components with login boxes and everything. I'm still working on this so that you also can use any web thing that you find on the web inside here.
The planetarium demo was as close as it comes to being similar to that. It would be very, very, very impressive. But you said that's all custom. Yeah,
it's custom. It's actually not Cables. In this case, it was Touch Designer, the on other program that I mentioned.
I see.
Because Cables is good, but it's still using the web platform. So why being limited to a browser when you know that this is going to be an offline experience and you need to run 2 4K projectors, right, and load the petabytes of data. So for this case, we use Touch Designer, and we paid for it, right? It was a paid program, and because they have calibration for projectors. But if you want to do anything that is distributed or on the web, then Cables is the way to go, at least for me.
Yeah, that's a very cool demo. And you worked on that planetarium demo?
Yeah, I did. I did the artwork.
Oh, okay. Yeah, that's very cool.
There's some other teamwork here also to add some interaction, but I did the controller, the sphere, and the artwork that was there.
Yeah, that's knocking on the door of the metaverse in terms of being able to be kind of interactive with your data, right?
Yeah, for sure. And I think now there are also people working here with XR in Cables so that you can create interactive experience using your phone, and having the nodes so that the main loop here is the main loop VR XR, right? So that's not the regular loop here. So that we even in Cables in the future we'll be able to create VR experiences and connect. Imagine you have this metaverse, then we have a node that is connect to metaverse, and it creates here. You just log in and that's it. You're connected, and we create the experience.
Yeah,
anything is possible, especially when you have both access to the code and also be able to use, if you don't know, other blocks, so that the community is growing and we have more and more basically blocks to play with.
Very nice.
Awesome.
Thank you very much.
Yeah, thank you very much for attending. Well, as I said, don't hesitate to reach out to me on any network if you want to connect.
Absolutely. I'll look for you on LinkedIn.
Sure. Have a great evening or day if you are from not Europe. And see you online. Bye-bye.
Yes. Thank you.